Alright, for this video we're going to look at developments. In the topic of developments, you have four main figures. These four main solid figures, cylinders. Cylinders have a circular base and they have parallel lines. You have cones. Cones have a circular base and the lines go up towards an apex, like a triangle. A prism is similar to a cylinder, whereas you have lines going straight up vertically. So I have two prisms here, and then a pyramid is similar to a cone, whereas the lines go up towards one point, which is the apex. So you can have different types of pyramids and different types of prisms. So we have here a pentagonal prism. It's a pentagonal prism because the base has 5 sides. So these 5 straight sides make a pentagon, which is a type of polygon. But over here we have a hexagonal prism because this base has 6 sides. So it's important to know your polygons before you do this topic, so that you know the different types, because you can have a triangular pyramid, you can have a triangular prism, you can have an octagonal pyramid, you can have an octagonal prism. So we're going to start with a cylinder. So the plan view of a cylinder is most often a circle. Well, it's always a circle, because that is the basic premise of what a cylinder is. It has a circular base, and so we have here a front and a plan view. So the first thing that we do is we divide the base into 12 equal parts, and then you number them. This first point here is 0. I'll just make these a little bigger. Excuse me. Alright, so now that we have numbered the base, you project your points upwards. So we know that this point here is 0 and 12 at the bottom. But it's also 0 and 12 at the top. So we're just going to project 1 up. You project to the top of the figure, and that will be your 1 point. So we have our 2 point over here. We also project our 4, our 5, So when you're constructing, it is important to know this. Now, another important thing is that when we get to point 7 lines up with 5, point 8 lines up with 4, point 9 lines up with 3, point 10 lines up with 2, point 11 lines up with 1. So you'll have 1 and 11, you'll have 2 and 10, you'll have 3 and 9, you would have 4 and 8, and then you would have 7 and 5. So we have done our projecting upwards. Now we're going to project across to start the polygon, to start the development. So I'm just going to project a long line across, and I will put a point here to start my construction. So this point here is 0. Now to get the distance across, you would take the distance from between 0 and 1, or any other measurement, or any other segment here, like 45, 6 or 7. So we take this measurement from here to 0. So we know that this point over here where the arc hits the actual line, that is going to be 1. 2, 3, 4, 5, 6, 7. 8, 9, 10, 11, 12. So these numbers it's important to number the drawing, number these points, so that you know exactly which point is which. So we know where our numbers are. So basically what we need to do now is to plot, and once we plot, we would make our development going across. So 0 comes across to me 0 and 12. One comes across to me 1 and 11. Two comes across to me 2 and 10. Three comes across to me 3 and 9. And then 4 comes across to me 4 and 8. And then 5 comes across to meet 5 and 7. And then our last point is 6, which comes across to meet 6. So, excuse me, we just plotted the points. Because this figure is a cylinder, you can use spline to complete this curve. So C to close it, and then we just trim off the top. So our development of this truncated cylinder will be here on the right, and that is our development. We will then turn off construction so we can take a look at it. So this is what our development will look like. Now, because this is a smooth circle, because the figure is a cylinder, you're not going to see any solid lines going up. It will not have those solid edges which you would see in a pyramid or a prism. So I'm just going to do a prism down here using a very similar figure. I made one change to it. So I'll make one change to this. I just draw this line here at the angle. And now we're going to make this into let's make it into a polygon, five-sided polygon, pentagon. So this figure is now a pentagonal. Should I use a pentagon? Let's use a hexagon. I'm just trying to do it quickly. So the center is here, we inscribe. Alright, so we have our hexagon at the bottom. Now the difference is between these two. You will still have your numbers here again, but the difference is that you will number the points. So one will be here. So you're not pointing the center, you're plotting the edges of the polygon, and that is the important thing. So it's very important to realize that 6 comes back. So we do the same thing again. We project a long line across. We plot a line here to start it.
Sir.
And then...
You remember me already?
Yeah. So this point here will be 0. So we copy across. So we do the same thing, whereas we take the measurement across, 0 to 1. And then we copy this, because this is our measurement for the construction. So that's 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6. So I'm just going to put some points to make sure that we know where these are. Then I'll delete these circles. So the same principle goes on again, where we project up, we project across, project up, project across. But it's important to make sure that you have the correct point where it's supposed to be. So we have our 0 to 6. So 0 comes straight up here, hits the bottom, hits the top. So we project across. So our 0 comes up, and our 6 comes up to meet that line. 1 comes across. So we project our 1 across. So realize that 1 is the same as 5. Now the figure has a cut here in the point. We'll do that in a minute. But 2 comes across here with this point. So we project our 2 across. So 2 and 4 are the same point. And then we have our 3, which comes across to the middle. Now because the point of this figure is not on any of these points, we need to find the middle between 1 and 2 so that we can project that point upwards. So we also need to find the middle between 4 and 5. So we extend that point across. Alright, so now that we have plotted our points, here's what our finished figure will look like. It comes straight across here, there's the bottom. The first point 0 is here. Now 0 comes across to 2 here, which is just above. And then 2 goes out to this point. And then it comes down here to 3, which is just below. And it comes over here to this point. So this is our construction for our development, which is here. So now these edges which are here, these edges are seams. So you draw your seams as hidden details. These are the corners of the polygon. So 0, 1 to 6, because there are actual edges, when I unfold this figure, I would see those as corners. Then I will put them as hidden detail. So when I turn off the construction, this is what the development of my hexagonal prism would look like. The only thing that I have missed, now these lines in this figure need to be solid as well, because these are actual edges. So it's very important for you to show clearly your solids, which are the actual corners of the figure. So if we had to draw this object and cut it out, it would produce this figure that we're seeing here on the page, with this front and this plan view. Now, a class is coming in, so I'm going to stop the video. But in this video, we looked at a development of a truncated cylinder. And we also looked at the development of a truncated prism. But what type of prism is it? It is a hexagonal prism. It has 6 sides. So what I will do is I'll make a second video where we look at the triangles. We're a second video where we will look at the cone and the pyramid. So for now, just watch the video, practice the drawing. and take a look at the exam papers to see if you have an idea of the corrections for the figure. Alright, so that is it. Oh, the last thing is you will never see lines inside of the cylinder because the cylinder is smooth. These lines will be solid because they're just creases. They're not actual edges.